Alright, today we're going to be talking about electron configuration and a special notation called the noble gas notation. So, what is electron configuration? It's the way we look at the arrangement of electrons and their different energy levels in an atom. Okay, and just a quick review, we remember energy levels is the number of periods that are in that atom. Okay, and we'll look at some examples here in a minute to make that more relatable. Okay, so these are our different blocks. We have our S block, our D block, our P block, and our F block. Should rearrange that and say we start out with S, then our P, then D, and then F. Okay, notice this is a periodic table. Does it have all the atoms' names, all the symbols, and all that on it? But we can see it's the same arrangement of what we normally see when we're looking at the periodic table. And we'll see some examples later where we pull up the regular periodic table and determine the electron configuration for those atoms. Notice here with the S block how hydrogen, which is up here, and helium, which is over here, they're both a part of the S block, okay? And they're both in period 1, all right? So here's another graphical representation of the different blocks and how it flows within the periodic table. Like we said, we have one S here, hydrogen, helium, then so on and so on. Notice group 1 and group 2 are all S block. Notice over here we have all our P blocks, okay? And then down here we start with the D block. These are our transition metals, okay? And down here is the F, 4F, and 5F. These are our rare earth elements. And we're going to talk about why this is 3D and why this is 4F later on, okay? There's a reason why. I know this is in period 4, and this says a 3D, but there's a reason for that. And so for here as well with 4F, I know it's in period 6. So you're asking me, Mr. Lane, why is it saying 4F if it's in period 6? We'll talk about that soon. There's a special rule for the D and F block. Okay, here's another graphical representation just showing the same thing I talked about. Notice our periods over here. Those are our energy levels. Okay, so we can see here, if I go back, you see these little stars right here. These are where our rare earth elements are entered into the periodic table. Okay, we move them down to make it look better so it's not all jumbled up like this. See how they're entered in through here? Nobody wants to look at this huge graph like this. We push them down here to the bottom. That's why we have the F block separated. But in reality, they're entered in right here in period 6 and period 7. Okay? All right, here's another one showing that the different blocks with them pushed in and not separated at the bottom. So we have S first, then P, then D, then F. Okay, we see that by we starting out with orange, then we go to blue, then we have green, and then we have purple. Okay, which is S, P, D, F. All right, so this is a standard electron configuration pattern for all of the atoms in the periodic table. We start out, of course, with the S, 1s2, 2s2, 2p6, and so on and so on. Okay, I do want to point out, look right here at 5s2. Or excuse me, yes, or let's start out for here first before we get down there. Let's start out at 4s2 right here, okay? So do you see how 4s2, if we go back to our periodic table, okay, with our representation here, see 4s, there's 4s1, there's 4s2. Notice how this goes to 3D. So for our D block, we're going to take our number of periods right here, which is our number of energy levels as well, our period number, minus 1. Okay, so for the D block, we're going to do energy level or period number. We know the energy levels are represented by the period number. Okay, minus 1. Okay? So if this is in period 4, 4 minus 1 equals 3. That's where we get 3D from. Okay? And if you move down 1, this is period 5, right? That was period 4. Okay? 4 minus 1, excuse me, 5 minus 1 gives me 4. All right? Is everybody following me so far? If you need to pause the video and come back and just recap on what I just said, you can. But just know the D block, our period number, which represents our energy levels, you minus 1 to give you the number for the D block. Okay? Now I'm going to go back to our picture. Wanted to say, looking here, starting at 6s2, that's when we have an F come in afterwards. All right? So for the F block, we're going to go back. For the F block, we're going to do the energy level or period number minus 1. Okay? So for the F block, we're going to do the energy level or period number, and we like to call that N. Okay? We're just going to say the energy level or period number to simplify things for now. Minus 2. Okay? So look here. So like we said, we're going to enter in these rare earth elements in period 6. Okay? Here's 6s1 right here. 6s2 right there. All right? And then we're going to put it in the F block. So I said for the F block, we need to do period number or energy level number minus 2. So if this is going in at 6, energy level 6, 6 minus 2, you guessed it, it's 4. So that's why this first row in the F block is 4F. Likewise, if I go to the end here with period 7, that's where my second row of rare earth elements are entered in. Those are our actinides. That's 7 minus 2, which gives me 5. That's why the second row is 5F. Okay? So that's the way we're going to start it, or the way we're going to do it with the rules for the D block and the F block. All right? So you need to remember, after you get past 4S right here, you're going to come up on the D block, which is our transition metals in the middle here. Our rule for the D block is the period number minus 1. All right? So we have to know that that starts out 3D, not 4D, 3D, because this is period 4 minus 1. All right? And then you need to remember past 6S, we start out with our F block. So after 6S2, 6X1, 6S2, we enter in the F block, and that's the period number. So for instance, that's 6, that's 7. Starts out here, 6 minus 2, which is 4. That's why we have 4F. And then we would do the D block, and then the P block. Or excuse me, we would do the P block first, and then the D block. Okay? Let's go back to our picture here. See, after 6S2, we have 4F14. Then the D block comes next, and then our 6P6, which would be right here. Okay? That's 1, 2, 3, 4, 5, 6. All right, so I may have misspoke there. I think I said the P block and then the D block. No, it's 6S2, 4F, 14, because we have 14. 1, 2, 3, 4, 5, 10, 11. Start out wrong. 1, 2. anyways, there's 14 here. And you got to include the one that's going up here with the D block as well, okay? So there's 14 total in the F block. All right? So it's 4F14, just like it is here. And then we go to the D block, which is 5D10. Okay? And then we finish out with this P block, which is 6P6. All right? And we do the same thing moving down to 5F. After 7S2, let's go to it. We have 5S14 and 6D10. All right? So that's the rules for electron configuration. Here's another image showing the different ones. Like we said, when we're starting with period 4 here. After 4S, we go to 3D. After 6S, we go to 4F. And then to D, and then to P. And same thing when we move down to 5F, okay? Just like it has, this is a sequence chart showing you 6S to 4F. Then you go to 5D. And then you go to 6P. So this is a really good image showing you the flow of electron configuration and the pattern that it goes in, okay? 1S, notice up here with hydrogen, how 1S goes to the right all the way over to helium before starting over with period 2, starting with 2S, okay? This is a really good graph here to look at if you have any questions about the flow of how the electron configuration is supposed to be in order. Okay, here's some examples. So first up, we have 1S2, 2S2, and 2P5. Okay, so first up, I want to mention these exponents up here that are raised. These represent electrons. All right, these represent my period number. These represent my block. Okay, what block I'm in. Period number. And the block it's in. All right. So here's our periodic table. So we got 1S2. So here we go. Here's 1S1. Okay. Here's 1S2. All right. Then we got 2S2, which are these two. Okay. Remember, this is the S block over here, groups 1 and 2, included with helium. All right. Now we got 2P5. Period 2. Here's period 1, period 2. 2P5. 1, 2, 3, 4, 5. Okay. So it must be fluorine, right? Let's see. Here we go. And another good way to check this to see if your answer is correct is to count up your electrons. We got 2 here, that's 4. 4 plus 5 is what? Is equal to 9. So I should have a total of 9 electrons. Does fluorine have 9 electrons? Well, I don't know. A little bit of review. The atomic number for fluorine is 9. And in a neutral atom, we know that the atomic number is equal to the protons. In a neutral atom, protons are equal to the electrons. So therefore, 9 and 9, which is correct. So that would be right. All right, another example. We got 1S2, 2S2, and 2P6. So a little bit more added on to this one. Let's look at the periodic table. So we know these two are fulfilled. 1S2, 2S2, okay? And it says 2P6 is fulfilled. So we go 1, 2, 3, 4, 5, 6, all the way to neon. Okay, so that P block is filled up. Okay. And then we said wants to go one more to 3S2. Okay, so this is period 1, period 2, period 3. This is our S block over here. Okay. And it wants us to go over 2. 1, 2, which is magnesium. Okay. And we could check our numbers again. 2 and 2 is 4. 4 and 6 is 10. 10 and 2 is 12. Is the atomic number for magnesium 12? Yes, it is. So your answer would be correct. All right, another example. I'm not giving you, notice I didn't give you the electron configuration this time and ask you for the element, but I told you the element and I want you to write out the electron configuration for me. So if you want to take a second and pause the video, we did the first two as examples. If you want to pause this video and try to work on bromine yourself and see if you know it before we do it, you can. Okay, I'm going to go ahead and work this out for you for bromine. Here's our periodic table. We're going to start out. First thing what I got to do is I got to find bromine on the periodic table. Okay, so we should be familiar with our periodic table by now, as we've did quite a few things with the periodic table thus far. So let's find bromine. Bromine's actually going to be down here, atomic number 35. So since this is a neutral atom, I should have how many electrons? Should have 35. Okay, so at the end, when we tally up all our numbers at the top, they should equal 35. And that'll let us know if we got the answer right or not, most of the time. Okay, so we know the first level is fulfilled. 1s2, okay. Hope I have enough room for this. Then our next level is 2s2. Okay. And then over here, moving towards the P block, all those are fulfilled. So that's energy level 2, period 2, 2p6. Okay. Next up, period number 3, 3s2. Okay. And then next up, we got our P block. That's 3p6. All right. And then we got period number 4. That's 4s2. Okay. Now, look at here. We have our D block coming into play. All right. These are our transition metals. What did we say earlier about our D block? It was our period number -1, right? So period number -1. So this is period number 4. So 4 minus 1 is equal to 3. So I know these all through here are 3D. Okay? So that's 3D, and there's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ending with zinc, because that's where the P levels start next. So that would be 3D 10. Okay? And then next up, we were trying to get the bromine over here. So we're trying to get the atomic number 35. So we got a few more to go. So next up would be the P block. We don't do any subtraction or anything for the P block. We just read straight from the period number here, which is 4. So we have 4P, and we got 1, 2, 3, 4, 5. So that ending will be 4P5. Okay? So if we add all those up, if you take your calculator and add all those up, you should get 35, which is the atomic number for bromine, which tells us how many protons bromine has. And like we said before when we were talking about atoms and things, the atomic number, protons, is equal to the number of electrons in a neutral atom. Okay. So moving forward, now we're going to talk about something called the noble gas notation. Okay, I mentioned this earlier at the beginning of the video. This is a shorthand version, okay, for elements that are further along on the periodic table that have a higher atomic number that we just don't want to write out all the mess, okay? So what we do is, if you look at this first example, AR we know is argon, okay? And then we're going to look at our periodic table. Argon's over here, atomic number 18. All right. So that's where we're going to start from. We're not going to start from hydrogen anymore. We're going to start from where argon is, because we don't have to write all of this up here, which would be 1s2, 2s2, so on, and 2p6, 3s2, and 3p6, okay? We don't have to write all that. So we're just going to put argon out front and then move from there. So it saves us time. So we have argon and then 4s1. So we know this is period 1, period 2, period 3, period 4. Here's argon over here. So moving forward to 4s1, which is here, that is potassium, right? So that answer should be potassium. All right, another example. Another one with argon. Okay, so we're going to look at our periodic table and locate argon. Okay, and then we have 4s2, which is going to be 2 past here. Here was 4s1 that we did a while ago, and there's 4s2, which is calcium. Now it wants us to do 3d10. Remember that 3d10, even though this is in period 4, this is still 3d because we said the period number minus 1. Okay. So this is 3d here for this row here. Okay. And it wants us to do 3d10. So remember 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That goes all the way to, you guessed it, zinc. Okay. So this next one should be zinc. All right. So our next example with noble gas notation is mercury. I didn't give you the noble gas notation. I just told you the element, and we need to write out the noble gas shorthand for it, okay? So let's find mercury. Mercury is a little weird, okay? It stands for hydrogenum for Latin, so that's where it gets the element symbol Hg from. Okay, it's down here, atomic number 80. All right, so we're going to back up all the way to the previous noble gas, which is xenon, okay? So we're going to start out, that's going to be our notation with xenon, okay? So we're going to write xenon in our little brackets, all right? And then what's next? We have, let's label our periods, 1, 2, 3, 4, 5, 6, 7, okay? So this is 6s, 2, so we're going to start out with. All right, and then next up, we don't have D block, we have what? Because remember, these two here go into the periodic table at that row. So remember how I said after 6s2, we have to incorporate the F block? So remember, we said for the F block, we do the period number minus 2. Okay, so this is period number 6 for this row. So 6 minus 2 gives me 4. So that would be 4F. Okay, so now we're going to do all of these because we're trying to get the mercury, which is in the D block. So we do all of these Fs, which is, there's 14 of them, like we said previously, okay? So that would be 4F, 14, okay? After we fulfill all those, then we have the D block next. And we're trying to get the mercury, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's actually the last one. So you have to count this one too. So mercury's the last one in that D block. And what do we say about the D block? The D block was the period number minus 1. And that's period number 6, so that will be 5D. So that has to be 5D10. Okay? And that should be our final answer. And let's... Okay. All right. We can cross out this right here. This is a typo. Should just be up to 5D10 for mercury. Okay. And that concludes our examples for the noble gas notation, and hope this video helped understand a little bit more about electron configuration and how to write the standard notation and the noble gas notation.